Coming up next on This Week in Computer Hardware, we talk all about the new Intel Skylake processor. We look at a ton of Z170 motherboards and the brand new LaVie Z notebook that's super light. All that and more coming up next on TWiCH.
Netcasts you love.
From people you trust.
This is TWiCH.
Bandwidth for TWiCH is provided by CacheFly at CacheFly.com.
This is TWiCH, This Week in Computer Hardware, episode 327, recorded on August 6th, 2015. It's Intel Skylake Week. This episode of This Week in Computer Hardware is brought to you by the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your home. Get $10 off the Ring Video Doorbell when you go to ring.com/TWiCH. Hey everybody, welcome to TWiCH, This Week in Computer Hardware, TWiCH's weekly show, its weekly foray into the world of computer hardware and technology. We actually have a very, I think, packed full week of interesting hardware news and releases, something that doesn't happen very often. Oh, first of all, I guess I'll introduce my co-host today is Alan Malventano.
Hello.
Patrick stuck somewhere in California in an airport, so last minute fill in from across the office is Alan. But regardless, we'll still cover the same amount of news that we were going to get to before. Obviously, the most important thing that happened this week is the release of Intel's Skylake CPU, CPU, not architecture necessarily, but it's an interesting release. So Skylake, for those who don't know, is Intel's next generation CPU architecture. It's a 14 nanometer process technology, the same as Broadwell. But Haswell is built on 22. So if you're a Haswell user or you know about Haswell consumer parts, this is another process node improvement in that direction. There are architectural improvements as well, but we don't actually know what they are yet, which is interesting. Usually when Intel does this, they have kind of a high-level architectural disclosure at one point, and then they have a more detailed architectural disclosure to tell you about what's changed in terms of either shaders on the GPU or shader counts or what's happening in the CPU pipelines and the core pipelines or the uncore design or the memory controllers. And then they released the processors. This time they didn't do that. They actually released two CPUs today, the Core i7-6700K and the Core i5-6600K, before really giving any of the details officially about Skylake. Now, plenty of information has been out there leaking and that we, have known about for a little while. But in terms of official architectural details, changes, what's happened, what hasn't, not a whole lot has been said by Intel. That'll all happen next week over at Intel Developer Forum in San Francisco. So we'll have more details coming out then, which is in not too distant future, obviously. But I think for many people, or maybe even most people, a lot of people don't really care what the architectural changes are to the processor, as long as there's performance improvements or clock speed improvements or some feature additions or something like that. And this whole platform has, I think, quite a bit of that. So if we look at the 6700K, kind of at a high level, what we do know about it specification-wise is that it's an evolution of the Haswell architecture, so it's not anything dramatically different. It's like quad-core processor with hyper-threading enabled, so you get 8 threads. It has a base clock of 4 gigahertz and a boost max turbo clock, I guess, of 4.2 gigahertz. Very similar to what we saw with the Devil's Canyon 4790K release. It is a brand new socket, LGA 1151, which means it is new motherboards, new chipsets. It is a DDR4 memory controller, right? So you are going to need new memory. You're going to need, it's going to be more expensive if you already have DDR3 and you were thinking maybe you just bring that with you for the upgrade. You're not going to be able to do that.
Yep.
DDR4 has improvements in memory bandwidth. It has deficits in memory latency, but overall the performance change is a net positive going from DDR3 to DDR4, even in this kind of early iteration. And remember that X99 used DDR4 already as
it's
well.
Been around for a little while.
Almost exactly a year.
Yeah.
Since the X99 platform, which is the 8-core and 6-core kind of high-end enthusiast or workstation class part. This is more mainstream consumer level stuff. It has updated graphics. It has about the same TDP as the previous parts. It has about the same price as the previous parts. Its MSRP is set to be $350, although we haven't really seen it for sale anywhere yet. Motherboards are out there, but no processors, which is obviously less than useful.
Right.
So that, I mean, that's pretty much what we know in terms of specifications. There are some power delivery changes to it, but we'll talk more about that when we actually get full details on it from IDF next week. The other major change is the interface between the processor and the chipset. That is upgraded from DMI2 to DMI3, which facilitates higher bandwidth between it. You basically are going from effectively 4 lanes of PCI Express 2.0 to 4 lanes of PCI Express 3.0, which doubles the available bandwidth between the CPU and the chipset. And what that allows them to do, and we'll talk about this a little bit later, is kind of like how it distributes other technologies to the chipset, right? You can add more PCIe SSDs, or you can add more USB 3.1, or you can add more USB 3.0 or whatever, right? And have better utilization of all that bandwidth and capability.
You can hit that limit pretty quickly with a bunch of USB 3.1 devices.
The old limit or the new one?
Even the new one.
Yeah. Oh, yeah. I mean, you can for sure.
Yeah.
And we'll talk about that when we get into the chipset side of things, because I think that's maybe more interesting than the processor. Like I said, the processor architecturally, we don't have a whole lot more information on. If you look at CPU benchmarks, the quick and dirty is that Skylake is another 5 to 8% faster than Haswell, maybe a little bit more than that in a couple of instances, and a little bit less than that in several instances as well. And I guess I should say it's actually 5 to 8% better than Broadwell. Broadwell is 5 to 8% better than Haswell, clock for clock. So we've been saying this for a long time. It's like, well, is it time to upgrade? Is it finally time to, move up? This is the part that you're ready to kind of build a new system around. And it all depends about where you're starting from. If you have a Haswell-based system, this is not a necessary upgrade. If you look at some of these benchmarks, you compare the 4790K to the 6700K, which is the top one up there, you'll see some noticeable differences. There are still obviously higher performing parts out there. If you look at Ivy Bridge E, Sandy Bridge E, Haswell E, those 6 and 8 core processors are going to be, significantly higher performance as you would expect. Where the Skylake starts to get interesting to me, just from a raw CPU performance standpoint, is if you compare it to something like Sandy Bridge. If you go, if you go to like the media encoding tests and you look at the X264 benchmarks, for example, and you look at the Skylake Core i7 6700K, gets you about 79 frames per second, and the 2600K, the original Sandy Bridge processor, gets you about 54. So 79 or 54. That's like your kind of raw performance, stock speed, performance change, which is actually pretty dramatic, right? You're talking about 35% or something like that in actual performance difference there.
Yeah.
And that's video encoding or transcoding, and it's one of those things that is, more CPU intense, more CPU stressful.
It's also one of those things where you're, it's a relatively long evolution and you're waiting.
Yeah.
Right. So you're knocking off 30% of the time that you're waiting for an encode to finish.
It's not like how much faster is it in Word or Excel, where you're not waiting long enough for the changes to really matter.
Yeah.
Video encoding, or if you do media rendering, 3D rendering, if you do anything like that, that is CPU dependent, if you're sitting there looking at your watch, or you're like, if you're ever doing something that maybe you want to look at your phone instead of wait. Yeah. For what the computer's showing, that's the type of changes that that you really can affect at this point. So I know one of the things we'll hear about with this is when we compare those performances is, well, I have a Sandy Bridge system and I overclock it, so none of these performance tests matter. So I mean, you can overclock Skylake as well, and it actually overclocks fairly well. I was able to get our speed, our 4.0 base clock stock speed up to 4.7. So 4.7 gigahertz on all cores at about 1.4 volts, although that can run lower. And 1.4 volts is not extremely high for this architecture, as we found. Some people were running 1.45 volts in their overclocks, for example, but other people were able to get 1.32 volts and get the same clock speed that we did. So I think You know, a lot of people are running their Sandy Bridge processors in the 4.6 to 4.8 range. I think you're going to run Skylake in the exact same 4.6 to 4.8 range with the exact same ease and capability that you did with Sandy Bridge, but you're going to get that 25% to 35% or whatever it is, IPC, you know, instructions per clock improvement of essentially 5 generations of CPU. You go Sandy Bridge, Ivy Bridge, Haswell, Broadwell, Skylake. Like that's a pretty significant jump. And the overclocking on this is dead simple. It's an unlocked part, so you can just go in there and change the multipliers. That's really all you need to do. Just change the multipliers and change voltages as necessary. There's other things you can do. You can adjust the base clock. You can swap with the memory timings or whatever you want to do.
Yeah, base
and
clock
actually,
isn't as big of a deal as it used to be.
No, it's really not. No, now once multipliers were like fully unlocked and you could go really high, it wasn't necessary to like pick one and then adjust base clock to try to find that balance. And that screenshot that we just brought up shows I did my testing on the Asus Z170 Deluxe, and that software integration for overclocking has actually gotten a lot better. And what I tend to do is I go into the Asus AI Suite 3, go into the TPU settings, and let it do its auto overclocking, where it reboots the system a couple times, overclocks till it crashes. It basically does all the things you would do in the BIOS. Increase frequency.
Does it much faster than you can.
Yeah. And you don't have to sit there and dabble with it, right? Like it increases clock speed until it crashes. It says, oh, okay. It reboots, increases voltage, increases clock speeds again, see if it gets that stable, and then it keeps going, increases voltages again. And it kind of does all that in a really quick
it could do like dozens of iterations without you even seeing the screen come up.
Yes.
You know, and then it just
So I know a lot of purists will kind of balk at that, but
it's a good starting point regardless.
Yeah, that's what I'm saying. It's like run it and see where it thinks it is, and then may go from there. Like, okay, I know at this voltage, at this clock speed, it's stable, so now I'm going to go a little bit higher and find out what you want. You do have to be careful. Like if I was at 1.4 volts, your temperatures are going to be pretty high, you know, 85 C or so. So make sure you have a good cooler. I think I was using Corsair H100i. We just got in a set of H100i GTX, which are 240 millimeter radiator, closed loop, self-contained water coolers, which are nice for that. You know, if you don't have to do that if you're not overclocking, you could probably just use your standard Cooler Master Hyper 212 or whatever and get away with it. It's not any different than Haswell or those other CPUs in terms of their TDP. So overclocking wise, they could be able to get the same that you would out of one of those older designs. Power consumption really kind of in line with everything. You know, like I said, it has better graphics. I don't think that's an important point to really discuss with this part, because if you're buying a 6700K, chances are you're not using the integrated graphics. And if you are, you're not using it for gaming.
Yeah, I mean, if you're buying it just because you're building a system and it's the new thing, you know, it's the newest, you might as well get Skylake if you're just building something new for someone, right?
Sure, yeah.
And in that respect, the integrated graphics, it at least has a fighting chance for a lot of people.
Yeah, but the argument there would be that this is a $350 processor.
Yeah.
And if you're buying if you're building a system for somebody that's going to use integrated graphics, chances are you're not going to spend $350 on a CPU.
Yeah, you'll go cheaper than that.
And there will be more Skylake parts coming out. They've only launched with these two, but at IDF they're going to tell us about the architecture. They're going to tell us about the other desktop parts as well as the mobile parts that will ship under the Skylake. Well, not under the Skylake brand, but under the Intel Core i7 6000 series or Core 6000 series brand. So we'll know more about those there. And there will be lower end, the quad core, non-hyper-threaded, maybe dual core hyper-threaded parts that will come out that will have similar GPU performance.
Right. But be a cheaper CPU.
But a lower cost.
Yeah.
Lower cost total parts. So it's hard to get super excited about any new Intel processor at this point because they are so iterative.
Yeah.
But I did, you know, for this particular review, we did some stuff where we looked at Sandy Bridge versus Skylake in a couple of specific instances, because I feel like there's so many people sitting on Sandy Bridge. It was such a revolutionary part that got people in the door to building their own systems again or for the first time, that they've just been stuck there. For example, I don't know if I'm going in out of order here on you, but I'm going to jump to the Skylake versus Sandy Bridge discrete gaming test here, where many of the people who are those Sandy Bridge users are PC gamers. that we, on this show and other shows have continually talked about, hey, you don't really need to upgrade your processor, but you should upgrade your GPU. Gaming is more GPU limited. Don't spend the money on CPU or motherboard upgrade. Go ahead and get that new graphics card. And looking back at the kind of 5 generation change. Actually, we want to change over to the other. We're going to look at discrete graphics benchmarks. So the story titled Skylake versus Sandy Bridge Discrete GPU Showdown. If you want to find that one for us, Burke. It looks at 4 real world games using a GTX 980 and a GTX 980 SLI configuration. Skylake versus Sandy Bridge. And the kind of quick and dirty of this is
there's a lot of people that think that no, it's just only my GPU.
Right.
Yeah.
Right. Or that the differences would be so minor you would never be able to tell that they're there. And so 2 things. One, for a single GPU at 19 by 10.
1080p.
Yep. You see some differences because the GPU is not being stressed as much. There are as much as, I think, Grand Theft Auto is 25% fast. Grand Theft Auto 5 is 25% faster at 1080p with Skylake than it is with Sandy Bridge.
Yeah. So for every time you're going to draw a frame in a game, there's some stuff that GPU or both GPUs has to do, but there's also stuff that the CPU has to do, and and interactions between the CPU and the RAM on the system, right? Other things that might be faster on a new platform.
And in this particular game, we're not talking about the difference between 160 and 180 frames per second.
Yeah.
In Grand Theft Auto 5, it's a very strenuous game, so we're actually looking at the difference of like 59 frames per second average and 73.
Yeah.
That's a pretty big difference.
And that's within a, perceivable range.
Absolutely.
Like you would notice that. As long as you had a display that was higher than 60 hertz for fresh. Yeah, you would definitely see that.
And frame variance is lower on Skylake.
It's more consistent.
And again, we're talking about a single GPU stuff here. Yeah, that's the graph that looks at kind of like frame time. So the black line is much more consistent and narrow through the majority of the band, and you can see on the orange line it varies a lot more. It goes higher. You can see how the average changes. You can see why the frame variance is different there.
And it's the same graphic setup in both cases. So anytime you see that orange spike riding higher, that extra amount of time was just the CPU and the memory. Yep, basically.
Now, what is fair to point out here is that at 25 by 14, that difference kind of goes away. Right. So now you're putting much more pressure on the GPU than you were on than on 19 by 10 at 1080p.
Right.
And so there's still a little bit of differences there, like maybe like 49 versus 52 frames per second or something like that, but not nearly as much to talk about.
Yeah.
And the frame variance, there's still some frame variance changes there, but they're just less severe. Now, the final thing I'll mention here is, again, if we look at GTA 5, because it's the most obvious example of this, is if you look at SLI testing, right? So we've always known that SLI is a more CPU dependent thing than a lot of people believe. Like the CPU has to do a lot of work, the driver's doing a lot of work to divide up the frames, combining them back, and making sure all that is happening in time and in kind of like a consistent manner. So if you look at that last set of results there, Burke, where we look at Grand Theft Auto 5 25 by 14 with GTX 980 SLI, you'll actually see that the average frame rate is dramatically better on Skylake, and the frame variance is dramatically better on Skylake. Like we're talking, again, now we're looking at 2560 by 1440, like a real enthusiast gamers resolution. It's not 4K, but it's the next thing up there. And 980 and GTX 980 and SLI goes from 57 frames per second to 80.
That's a pretty big jump.
That's a big jump.
Yeah.
I think it's like 42% or something like that.
And again, that's the same graphics cards.
Same GPUs, same drivers.
Yeah.
You're just talking about the Sandy Bridge platform versus the Skylake platform. I've already had people in the comments say, oh, well, I overclock my Sandy Bridge, so it won't change that. Well, it's like you can overclock, I said.
The same exact argument applies to
you overclock Skylake, and it'll do the same thing.
Right.
And again, frame variance is dramatically different there as well. And what we found is, like in BioShock, Grand Theft Auto, Grid 2, and Metro with single GPU, the differences are kind of minimal, even at lower resolution. But once you get into SLI, everything was about 10 to 14% difference.
Okay.
Which is noticeable.
So that's a CPU or a like motherboard side overhead associated with SLI.
Yep.
Right.
Yep. Because I mean, Sandy Bridge was PCIe 2.0. This is PCIe 3.0. That
alone probably makes
adds to it, but it's probably not a dramatic thing because latency is still the same, and bandwidth, I don't think you're really pushing
Well, maybe. I mean, there might be little
8
things that
lanes
add up.
Yeah,
right?
I mean that's what it is, right?
Yeah.
You've got IPC changes, you've got DDR4 memory, you've got new PCIe 3.0, and all those changes add up to some amount of actual real-world gaming performance changes that you didn't have before. So if you have a Sandy Bridge system, I'm not telling you that you need to go upgrade, but I think it's a much more compelling discussion to have now that we've had this long. Was it 4 years or 5 years of CPU architecture between when they built their system maybe and when this system came out? So
yeah, it's good data to look at if you do have one of those older systems and you're wondering, maybe it was time for me to think about, yes, I'm overclocking, but that's only getting me an extra 20%. And I could have already got that extra 20%.
Overclocking gets you extra clock speed, but it doesn't get you architectural changes.
That's true.
Right. And I know that you're on an Nehalem system. I know Patrick's on a Nehalem system too. And this same thing applies to you guys in some way, maybe a little bit more, maybe a little bit less because of the art platform differences there.
Right.
But it's the same thing. Like if you're looking at architectural age, this is what is happening there. So that's a first couple of things about Skylake. But I also did want to talk about the storage side and the chipset specific side of things. And this is something that I had you work on while I was doing all the CPU stuff, which is we talked about it: new socket, new processor, new chipset. Z170 is the name of the chipset. Asus, MSI, Gigabyte, ASRock, they all have boards out there for it.
Yep.
The biggest change is we talked about the interface. It's now PCIe 3.0 instead of 2.0 between the CPU and the chipset. Now the chipset has 20 lanes of PCI Express 3.0 on it.
Right.
That it can use to distribute in multiple ways, some of which...
it's basically a huge bridge.
Yeah. Okay.
Right.
Yeah, that's a good way of looking at it.
It's basically just a huge PCIe bridge, right? And 4 of those lanes is how it talks back to the CPU. The rest of the 16 can be divided amongst whatever the motherboard maker wants to hook it up to, basically, right?
Yeah.
Some of those have to go to the things that usually were associated with the chipset. So some of those lanes would have to go to the SATA controller, right? Just the regular Intel SATA controller you're familiar with. It's been on every motherboard since the beginning of time. Well, or at least until they started including SATA. And, some of that goes towards USB devices. Some of that goes towards other things. But there's enough extras that it just kind of makes things a little bit easier. As far as if you have M.2, you want to make sure you have 4 lanes to go to an M.2 port.
Right.
You want to make sure you have some extra lanes to go to things that there just wasn't enough PCI lanes coming off the CPU for. Don't get kind of X99 stuck in your head here, because that's where you have a bunch of lanes coming off of the CPU. You don't have that with Skylake. You only have 16. So now you have, just an extra 16 to just wire to other things, right? Additional PCIe slots, those sorts of things. So it is good to have the extra speed, right? Because you're basically doubling the throughput that you could get. But as Burke just slipped up there on the screen, there was another interesting addition, and that is that not only do you have PCIe devices hanging off of the chipset, which is typical, right? If those PCIe devices happen to be SSDs, and you're willing to do some manipulation with some tweaking of settings and BIOS to get everything lined up to enable it as such, you can do rapid storage technology RAID of PCIe SSDs. So this is like SATA RAID, SATA chipset RAID, but applied to PCIe devices, which is really complicated to pull off. It's not like just, take some more SATA devices and make a RAID out of it. This is PCIe, even NVMe devices.
Right, I was going to say that it's not just PCIe. It's like PCI Express and NVMe, and then be able to kind of convert, interoperate between those two.
Right, and NVMe is a tricky thing in and of itself, because it has a driver that it actually sends to the UEFI BIOS during boot, so that the BIOS knows how to talk to that SSD.
I'd be curious, well, we don't have to get into it, but how much NVMe is kind of, or how much, if you have an NVMe and just a standard AHCI,
what the difference might be and stuff.
If AHCI holds back the performance. I mean, I guess you would have to, right? It's kind of like if you SLI 2 graphics cards, you're limited to the speed of the slower one.
Right. You're still limited by the speed of the slowest one. Interesting. First of all, just that is a thing that works.
Yep.
It's kind of tricky to get working. There's actually, this article started out as one page. We initially could not get the PCIe part working properly, and there was this little mystery setting we had to go flip elsewhere in the BIOS that just magically made everything start working for us. So there's a bit of a steep learning curve, and maybe some things that the manufacturers are going to have to make a little bit simpler. But hey, it just came out.
I think the user interface for setting this stuff up needed to be.
It could be a little bit better, but it'll get there. But hey, as you can see on page 2 of this that we had to create actually this morning, just before we recorded this, we were able to get it working, and it works as advertised. Basically, you have up to about 3.5 gigabytes per second. That's the maximum throughput you can get out of DMI.
DMI3.
DMI3.
Yeah.
So even though you can have a pair of PCIe SSDs that are both connected, each by PCIe 3.0 by 4. Okay, you have the M.2 slot. That's a PCIe 3.0 by 4.
Yep.
And you have on this motherboard we were testing, the Z170 Deluxe. The third PCIe slot, basically the last PCIe slot on the board at the very bottom. And each one of those is PCIe 3.0 by 4, but you're still limited by the single PCIe 3.0 by 4 link back to the CPU.
Correct.
From the DMI chipset. That works out to 3.5 gigabytes per second once you take away a little bit for overhead. It should be 4 gigabytes per second even, but that's just not how these things work.
Well, keep in mind there's other stuff going on over that connection as well.
There is, but like when we did this testing, like we didn't have, no other devices were connected. There wasn't anything else that it really should have been communicating with. Realize though, you do have to share that 3.5 gig per second with other things.
Right.
So if you do have a bunch of USB devices that you're also using at the same time, you're not going to be able to get the maximum.
Or USB 3.1 or USB 3 for that matter.
Exactly.
Right?
The other devices are going to have to share. Now, granted, those devices are probably going to sip bandwidth compared to a pair of, fire-breathing SSD 750s connected to your system, right? Which is exactly how we tested this. So you won't be able to double your read speeds for that particular SSD.
Yeah.
Because the read speed is already more than half of that 3.5 figure, right? So you hit the other bottleneck before you can max out both SSD 750s. But the write speeds, since a single SSD 750 is like 1.2 gig per second, that's less than half of 3.5. So we were able to, exactly. So we were able to get, as you might think, 2.5 gig per second writes going to a pair of SSD 750. So the scaling was effective there. And I will say that just from tinkering around with different settings and different configurations and testing, you're basically going to double your sequential speeds of whatever pair of SSDs you hook up here up to 3.5 gig per second, or up until you saturate. You're hitting a bottleneck elsewhere. As far as random performance, SATA devices didn't have super high like 4K random performance in the first place. Granted, they were much higher than hard drives, but compared to how fast a computer can process things, it was still a relatively small number, right? So you might get 50,000, 80,000 IOPS from a SATA SSD. And the Intel controller has always been really good in the past about scaling that number up as well. So you add a second SSD to a SATA RAID, you'd go from 50,000, IOPS to like 100,000 IOPS. You get to up to about 4, and we've actually hit like 200,000 IOPS.
Right,
just
some
in
kind
testing.
of other bottleneck.
Yeah, and then you start hitting a different bottleneck. Same kind of thing applies here. There is like an upper limit of like IOPS of what the DMI, just not just the DMI, but like what the chipset can handle, right? Because all those IOs, each one takes time for that bridge to be able to process, and it's trying to RAID them together, right? All that stuff takes system resources to do. So in our testing, we saw that the IOPS performance was only about a single SSD 750.
It didn't really change.
So even though we had two together, when you really hit it with random stuff, you're basically saturating the processor of the chipset as opposed to. This
isn't limited to Intel 750 series SSD though.
It is not.
You can use any PCI Express SSD.
It doesn't have to be NVMe, right? AHCI or NVMe. Asus, we haven't tested it, but Asus even claimed you could mix them both together.
Interoperate. Yeah.
I mean, maybe that's a good idea, but the preference for a RAID, especially a RAID 0, is you want to match the two devices. Otherwise, you're limited by the slower device, and you run into weird timing issues of one SSD is going half the speed of the other one, and it's just not ideal. But it's worth trying if you
Sure.
have, if you have the two of them. Also, we haven't done extensive testing on it, but it does open the door for if you like PCIe SSDs, but you don't like the idea of having a single SSD with all your stuff on it, right? Maybe you don't want the performance. Maybe you want a RAID mirror of PCIe devices.
Okay.
Right?
Yeah. It just sounds so odd.
It
But,
sounds
it
odd,
makes sense.
but maybe
Kind
PCIe SSDs are still kind of new, especially NVMe ones. Maybe you're worried that one of the ones you bought was going to fail. You want your stuff mirrored across two of them? That is possible. You can create a mirrored RAID with this, just like you could with SATA devices. And you're still going to get double of the read performance.
That's right. That's true.
Right?
Yeah.
So the write performance,
so you still get some advantage.
Yeah, you'll still be limited to whatever the single, a single PCIe SSD was for that particular model for your writes. But you're still going to get double the reads. You're still going to hit most likely 3.5 gig per second anytime you're reading, anytime you're loading a game, loading Windows, any of that stuff. Speaking of loading Windows, yes, it is bootable. In case there was a question there.
That's important. Yeah.
That's bootable. That works. We tested it. Installed Windows to a pair of PCIe SSD 750s. Booted really dang fast. I mean, it's already really dang fast in the first place.
Do you get the impression that this is kind of like a warm up to being able to enable this on the next, like
within the CPU
Skylake E type of thing? Like, because I mean, in reality, you're combining 2x4 PCIe SSDs,
right,
that have to filter back through 1x4 PCIe channel to the rest of the system.
It's not ideal.
So it's not ideal.
Right.
It's almost, I don't want to say proof of concept, but it's more like we realize that this is not going to be really utilized to its best extent in this platform.
I agree, but I think it's already a very tricky thing. So it will be another layer of tricky thing to make that work.
Sure.
With
I mean, you think of like X99 has 40 lanes. If you get a 5960X, it has 40 lanes of PCI Express.
Right.
You have 2 PCIe SSDs in there running by 4.
Yeah. With that feature here, it would be silly for that feature not to exist for like a Skylake E.
Right. Oh, I'm sure it would have to at this
You'd
point.
almost have to, right? Because then it was like, what, you can RAID PCIe SSDs on the
I just
lesser
wonder if
system?
there's something like architecturally that they couldn't go back and enable this on X99 that exists today.
I think it's just this UEFI appears significantly more complex to go along with Skylake. So I don't think that Intel would go back and re-engineer and add all of this stuff, backport it to the BIOS, because it's all at the BIOS level, and it would have to all work with all the manufacturers and everything. Like that's a huge undertaking, even if it was possible.
Yeah.
Right. I think they're just going to probably just focus on the moving forward stuff with it, and I can't really blame them if they do.
Sure.
I mean, as much as I would like to be able to take an X99 board and do this kind of a RAID across
3 or 4.
Well, we did it,
drives.
right? I mean, we did that testing.
But it was using Windows RAID.
Yeah, we had to use Windows RAID. The performance was horrible. The only way it was performing any kind of decently was just by me having our benchmark tool talk to the drives individually.
Right.
And they were not in a RAID. And all we could do was kind of do a hypothetical, imagine if they were together, this is what they would do. That would be possible if the BIOS could, chain them all together. And then just realize there's a lot of weird like BIOS level switches that have to flip for that to happen. Like when you turn this on in the BIOS for Skylake, for a Z170 board, those PCI devices are no longer show up as regular PCIe devices, and then they show up underneath DMI as like, as if it's its own device. Like before I established the RAID with these drives, the Intel driver for the SSD 750 would not load for these SSDs because they appeared as like, it's a device that's like within the DMI. It's like a separate device.
Right.
So the native Windows driver for it didn't even see them. Right. I had to go back in the BIOS and switch those switches off. Which again
gets back into kind of like the usability aspect of this. It's a brand new thing. It's difficult. Like how it's being communicated even in the UEFI is poor still.
There's a lot of tricks that they're having to do to make this a rateable thing. Right. But either way, very cool, very high speeds.
Yeah. Somebody in the chat room asked if this was Windows 10 or whatever. We did this on Windows.
I did on both
8.1 and 10.
Yeah, it just I don't think the Windows version seems to matter. I mean, it might even work under 7.
Right.
It's just it shows up as a different device. You might have to load the driver during the Windows installer. Actually, even with Windows 10, we had to if you set up the RAID and you can set up the RAID within the BIOS, before you start your Windows install, you have to do the old trick of have your driver on your same USB drive.
It used to be jam the F6 key. Now it's just nothing shows up for you to install to, so you have to install a driver.
So you still have to load like the RST driver, but that RST driver works all the way back to Windows 7, or even like I think it goes even further back than that. I'm not sure how XP would handle something like this, but it might.
I say I don't want to try. We got too much other crap to do. So actually, I think what we're going to do is I'm going to take a quick break here before we start talking about all the motherboard stuff, Burke, and talk about this week's sponsor of the show, because I don't want to wait and get too far in without touching on the fact that this episode is sponsored by the Ring Video Doorbell, which I have here. So I know a couple weeks ago,
we put it in.
You on it on the show with Patrick, where there was an ad for this.
Yeah.
I had just gotten it, but I wasn't on the show to even talk about it.
That box was sitting on the desk here, and I was doing the show from home.
So here's what the Ring Video Doorbell is all about. Over 95% of home break-ins happen during the day, and burglars almost always start by ringing your doorbell to see if someone's home before pillaging your possessions, which sounds like the most obvious thing in the world, I guess, but it makes sense. With the Ring Video Doorbell, you can see and talk to anyone at your door from anywhere in the world using your smartphone. Ring's advanced motion detection alerts you, even if someone doesn't ring the doorbell. It's like caller ID for your home, and you can actually, in the software you set up, you can configure like how far out do you want the kind of messages to be sent to you based on it. That way, if you live close to a street and cars are driving by all day, you don't want it to set off an alert for you every time a car drives by, so you can adjust it and tweak things a little bit that way. It's super easy to install. It takes about 1 minute, and it works with either your current wiring or with its built-in rechargeable battery, which is an interesting thing I'll talk about.
It is extremely wide angle.
Very wide angle.
Like, they're not kidding when they say 180 degrees, because we set it up here and we had Ken was like squinched up against the door on the corner.
He was trying to hide from it.
Yeah, he was trying to hide, and he was still in the frame, which I was just shocked that that's even possible.
So it comes with this is an empty box, because I've actually got the unit installed. This is where it would be normally, but it comes with comes with things that you might need. It's very similar to another product that you may have heard of in terms of ease of installation. They provide you with all tools. There's a little screwdriver up here. There's a bit here that has a hex, as well as the kind of it's not really a security bit, but the bit on the bottom that
it is it's kind of a security bit,
and then you have this masonry drill bit here if you've got to drill into concrete or a brick or something like that. It's something that most people may not have. Even if you have a drill, you may not have a masonry bit. So it's nice to just kind of have all those accessories here. The part about installation that I liked is the fact that it could hook up to your existing electric doorbell wiring, or it, like how we have it here at the office where we didn't have a doorbell before, is it's just running on a battery. So if you plug it into the existing wiring, I think it will do more things, like it will illuminate the LED light full time. Whereas if you're running on battery, it will not. It just kind of, it's kind of in a more dormant state until somebody hits the button. But the ease of use is super awesome. Somebody comes to the door, puts the button, it rings. If you don't have an internal doorbell, it just rings through an internal speaker on the device. It's loud enough that we can hear it inside our office when somebody hits it out in the hallway. So that's good. And then it rings your cell phone, and you get a little notification that says, hey, there's somebody out there. And then you can see who it is before you decide to answer it or ignore it. I got it here. There's security reasons to have it at home. Like this guy who's getting a package delivered at his house. And that's really what I wanted it for, was like, okay, sometimes I go out to lunch, FedEx shows up and says, oh, I've got a signature package here for you. They hit the button. I can call them. They call me, and I can say, hey, you know what? Just go ahead and sign for it. Leave it there. I'll be right there. And they feel better about it. I feel better about it. And everything works out. If like my wife just had a kid and maybe she's upstairs and the doorbell rings and she can look on her phone and see who it is before worrying about getting out of the room, or maybe she's feeding or whatever. And it's just some, door-to-door roofing sales guy. You can just like ignore it or talk to him and say, hey, what do you want? I don't want any of that. Please leave.
I do like the idea of being able to screen your front door. Because that's basically
as soon
what
as you
you're
open
doing.
that door, that's when they get you.
Right.
So they jump in at you.
If you just don't answer the door, because you already know who's there, right? So that's great.
Yeah.
You don't even have to. They don't even get to see you peeking around the corner to see who's at the front door.
That's right.
It's just
It's like magic. Except it's not magic; it's technology and the internet.
That guy looks shady right there.
Yeah, I wouldn't let him in. I wouldn't let him in. So right now you can get $10 off the normal price. You can protect your home and have peace of mind with Ring. Go to ring.com/twitch. That's TWICH. Ring.com/twitch, and you can get that special offer. And I really do think it's a neat piece of technology that will start a conversation, if nothing else, as well too. Every shipping guy who's come in who's hit the button on it. Because first of all, they went from having no doorbell to suddenly there's this neat looking device sitting there with a button.
And they definitely hit the button. Like
they all hit the button.
We were worried that people might not know
I thought they might ignore it and just continue to knock on the door.
No, people like as soon as we put it up, like immediately people just started naturally hitting the button.
Neat. So we thank Ring for their support of This Week in Computer Hardware. Nifty device. Okay, now let's talk about, we talked about the chipset.
Right.
We'll very quickly kind of run through a whole bunch of these motherboards. Asus, MSI, Gigabyte, they've got all this stuff out there. Asus they have a whole new Republic of Gamers line of motherboards for the Z170 chipset. I like the new designs. This first picture makes it look like metal along the top VRM stuff.
I'm pretty sure
it's plastic.
Yeah.
But it looks pretty nice. This is the Maximus 8 Hero. It has customizable RGB LED lighting that you can change based on the temperature. And I think this one, the Asus ROG color has always been red. Now you can actually change it.
Well, I think those red accents are
on the chipset part. You can actually change the color.
Yeah, there's LEDs that are just RGB LEDs. You just whatever color you want. Which is great.
Because I'm not even going to talk about our brainstormed idea on motherboard design, because I think I'm going to have to sell it to somebody. Somebody will still steal it from me. Asus likes to steal all my great ideas, like
that's true.
LED, adjustable, colored lighting, cooling.
We shouldn't have said that out loud.
No. But they've got that. They also have their channel series boards, or what they're calling their signature series boards. This is like the Z170 Deluxe that we did our review on. That motherboard that we did our review on, and you did all of your PCIe RAID testing, is a $350 motherboard, I want to say, something like that. It's like their most expensive Z170 board, but it has 6 USB 3.1 ports. It has 802.11 AC 3x3 wireless. It has 6 SATA ports, a SATA Express port. It has a full-size M.2 port. It has a, what's that adapter for the U.2 thing called?
The HyperKit.
HyperKit, which allows you to use that 2.5-inch form factor of the Intel SSD 750. It comes with a PCI Express riser card that lets you attach an M.2 device to like the third PCI Express slot if you want, or the second PCI Express slot, I guess, if you want. And it does it all. Great integrated audio, supports 2-way SLI and Crossfire. I think it will actually support 3-way Crossfire technically. Dual gigabit LAN, both powered by Intel controllers. A lot of good stuff on this board. And again, some of that functionality, like the 6 USB 3.1 ports, are powered by 3 as media controllers. Each of those as media controllers uses 2 lanes of PCI Express. So having those 20 lanes, from that chipset
is handy.
Even if it's just a bridge, is handy because you have the ability to connect to more things that then gives the user more options in terms of what they want to actually use on the system. As opposed to if you only had 12 lanes on the chipset, you only had 8 lanes to play with, you were like, okay, well, I don't want to put SATA Express and an M.2 and USB 3.1 because they'll only ever be able to use one of those things at the same time. Stuff like that. And they also have, Asus has boards, I think they start at like $140. Patrick actually called me yesterday. Was yesterday Skylake Day? Day before? It was yesterday.
Yeah, yesterday.
I'll go with yesterday, sure.
They're all blending together.
He called me yesterday. He was like, I saw some Z170 boards on Amazon for like $139. Is that real? I was like, yeah, no. I mean, this is not an X99 platform, right? Where all the motherboards are expensive. You're going to see some modest priced parts there. MSI has look at this board, the Z170 featuring X-Power titanium.
That is wicked looking.
That white PCB with white coolers and white accents on everything is pretty. It's pretty neat. And apparently it has the distinction of holding the highest DDR4 overclock to date.
I mean, that is a really slick looking motherboard.
Yeah, it's neat looking. I think that's a rendering. If that's not a rendering, then it looks really awesome. If it is a rendering, I want to see what it looks like in person, because just the
looks like
black
the actual
on white,
board.
and like you see how the PCI Express slots are kind of colored as well. In that way, I think that's pretty impressive stuff. And apparently the DDR4 was running at 4.6 gigahertz on that. So, and actually there's another picture a little bit further down that actually, again, still looks really nice. I don't know. We'll have to see. I wonder what they do with lighting on that. One of the things you could do with like an all white board is any LED lighting you put on it will change its appearance pretty dramatically. So that'd be useful. And then Gigabyte released their 100 series motherboards. They have orange and black, white and red, and gold and black, depending on which channel series you went into. But they also have kind of, it must have been something that one of the PCI plastic manufacturers came up with and kind of pitched to everybody for this generation, is the kind of the two-tone on the PCI Express ports there, which looks pretty cool. I guess that's like a silvery color on it. Is that right? You know, it kind of adds a little accent to it. Gigabyte has the gaming series, the ultra durable, which is like their kind of basic set, and then the overclocking series. Again, same feature sets, similar feature sets, I guess, to everything else. We'll have to wait until we start getting these motherboards in to talk with Maury. He's going to do all the reviews for us and see which boards really stand out in terms of either features or compatibility or performance and stuff like that. Speaking of, we don't have any Z170 motherboard reviews done, but we do have a board preview, which is almost a review in my mind, that Maury posted of the Z170A, which is their lowest cost board. Expect 150 or less for this motherboard. Very similar looking to the Deluxe, just, you know, missing some of the features. It only has 2 USB 3.1 instead of 6 USB 3.1, right? So those types of changes. Only has 1 gigabit networking connection instead of 2, which I think most people would probably be okay with in the grand scheme of things. So if you want to see some quick early performance results, as well as kind of compatibility and UEFI testing, you can do that in Maury's Z170A preview story. Okay, so that was Skylake. that was this week in Skylake.
Yeah.
Hopefully next week we won't have next week in Skylake as well. There were a couple of other things we're going to talk about here. We posted a review of the LaVie Z notebook. You talked about that a little bit on the podcast about the kind of experience of seeing it for the first time.
Yeah, at CS. I think you also talked about this on Twitch, but it would have been back in January.
Yeah, back in January. So it's kind of your standard. It looks like your standard Ultrabook notebook, right? It's powered by a Broadwell processor. It's a Core i7 CPU. There's a touchscreen version and there's a non-touchscreen version. There's a version that is like the Lenovo Z360 that folds back like a tablet, kind of like a Yoga. There's one that does not. But and
as soon as you pick it up, it feels like a prop.
Yeah, like not normally do we post pictures in our stories of like laptop on a scale, but
and that still doesn't do it justice.
It really doesn't, because when you say, oh, this laptop is only 1.87 pounds,
right?
You think, well, okay, there are some other laptops that are like 2 point something. Right. It's not that big of a difference, but it is a 13.3 inch device. It's not a small. It's thin, but it's not like tiny. It's not like a netbook size thing that existed back in the day. But as soon as you put it in your hand, somebody puts it in your hand, right? You have this immediate reaction to it that this shouldn't exist.
It crosses this threshold where you just feel like it shouldn't be a computer.
Yeah, I mean,
like it just, you know.
Ken did the review for us, and he kind of had this thing where he went around to everybody and like anybody that knew anything, he's like, here, look at this, and they all kind of had this, whoa, you know, like
pick it up.
Yeah, like when you pick up something that you think is too heavy and you go too much, and there's definitely part of it that's that. And it's able to do that because of what's the it's a lithium magnesium design, co-designed by Lenovo and NEC, which is why this machine very much looks.
That does not mean that the case is the battery, just so you know.
Yeah, that's true.
There just happens to be lithium mixed with the magnesium. But
it allows them to make an incredibly light, fairly structurally sound device.
Yeah.
I know at CES, for example, we did some torquing on it.
Well, part of the design is that it is designed to flex.
Right.
Right.
Meaning what?
Meaning that instead of break, right? Like usually if you have like aluminum or some other kind of just straight magnesium kind of like assembly, right? Like they tend to be hard and brittle kind of a metal as opposed to a flexible metal, right? And if it's something that's flexible and can stay strong as it's being flexible, then you can get away with making something with a lot less of the metal in it, right? You just have to realize that, hey, it's not going to be this extremely rigid thing. You can actually grab the screen and you can twist the screen like diagonally, like actually like.
Don't do it a whole lot.
No, I wouldn't want to do that a whole lot. But they actually designed it in such a way that the screen is like, I think it's bonded to the back on this one.
Yes, that was what I was going to say.
Right?
Is that the screen is actually bonded to the material.
Right. And that kind of helps it be a little bit more rigid. But, you know, the actual, based on how lightweight the bottom of the laptop was, because you can remove the bottom of this, and it really is like just a rigid sheet of paper. It's weird.
What was the thing I said? I said last night is like you could hold it like a piece of thin aluminum and like shake it so it makes the thunder effect. Yeah, you know.
Yeah, it makes that kind of a sound, and it's really cool the way that just that kind of engineering approach that you can just take this different kind of material and hey, look, this is really kind of flexible and doesn't tear and doesn't break, that kind of thing. Let's make a laptop out of it. Like who would have thought to do that?
It felt like the other thing that Ken pointed out is it feels like when you go to a furniture store and you pick up like the demo laptop or
the
demo
fake,
TV,
the fake laptop that's just made out of cardboard, right?
You go, oh, that's obviously fake.
I feel like pieces of cardboard that you would assemble, like thick cardboard, might be heavier than this thing. Yeah.
So the LaVie Z standard is $13.99. The LaVie Z 360, which is the one that has the screen that hooks all the way over, is $15.99. It's priced competitively, but it's not a perfect machine. There are some issues, right? The screen is an IGZO, which is cool for low power and pretty good image quality. Yep. But it has a very low maximum brightness level. So like outdoor usage was kind of a pain.
That's true. It was really
like Ken was trying to like take pictures of the screen, and even at maximum brightness, it was hard to do.
It was like a typical laptop, like at medium. Like at the brightness
I agree.
In the
I think he said it was maxed out like 160 lux.
Yeah.
Or thereabouts. We also had a couple of dents in the back of it.
Yeah, and that was just
being in his backpack and kind of jostling around with other things.
Yeah.
Right. Maybe it's, you get in your car, you put your backpack down, and maybe part of the laptop top touches the top of the passenger seatbelt buckle.
Sure.
Right.
That would dent it.
Is that going to dent it? Right. And it didn't like change the device structurally or anything.
Right.
It didn't crack anything. But and they're not super easy to see, but we adjusted the light or so in the photo to make sure you could see where it happened. So we'd like to see them maybe strengthen that up some, improve the display a little bit.
I think for a laptop that's this light, you might just have to come to the realization that dents are like scratches.
Like getting a balsa wood laptop is probably going to shatter. Don't do that. Right?
But this,
maybe make a more realistic comparison. Having a balsa wood lightweight remote control plane.
Okay.
Like I had those.
Right.
Right. And the idea was like it's super light. You don't have, it doesn't go very fast.
But it just snaps in half.
But if you touch the ground with it, done. Right. And it's obviously not quite this bad with the LaVie Z. I'd also like to see it be more of a Lenovo ThinkPad. Right. This is very much, it was a co-design between NEC and Lenovo.
The keyboard was obviously NEC, not
keyboard,
Lenovo.
Obviously, like most of the design is very obviously like there's no like Lenovo software I think was there some Lenovo software?
I don't think so.
I don't think there was none. Right. So that's odd.
Right.
So I imagine what we'll see in the next generation of this, maybe based on Skylake, will be another kind of revision that takes the same materials, changes things around a little bit, and makes a true ThinkPad that is lighter using some of that stuff.
Yeah.
So I don't know.
We'll see.
What else did Patrick throw in our notes here for us? Are we still worried about IoT security? We've had a conversation about this week.
Yes, Alan. We have.
What is this? What's this story that Jeremy posted up about here? This is about apparently open FTP and telnet ports on the pumps for like IVs at a hospital.
Yeah. Which is not a good thing.
Well, first of all, I also found it funny is when my wife was in the hospital for all the baby issues we had, there were like, not this brand, but there were probably 3 of these kind of just sitting on the counter. in our room that I just started messing with them because they like connect to each other and they have these weird data connections, whatever. I looked them up and they're about $600-800 a piece.
You were looking up everything in the hospital.
I love to do that in the hospital. Is I would find the model number of some device and I'd find how much it costs. In the neonatal intensive care unit where my daughter was for 3 weeks, I did that all the time. Like the monitor that reported heart rates and breathing rates and all that stuff.
How much was that?
$24,995. 25 grand.
Holy crap. Yeah.
Yeah. And it's just
for a monitor.
It's a monitor with some monitoring software as a part of it. Right?
Makes you want to buy G-Sync instead.
I wouldn't.
G-Sync isn't pricey compared to that.
Child up to a G-Sync monitor. I'm just going to put that
It'd be variable refresh rate.
Yeah.
Heart rate.
I need static maximum refresh rate. I don't know what the computer was inside of all that stuff. But anyway.
So basically there's just devices that have open ports, which is bad, right? Like generally.
And we saw the Chrysler stuff recently. We've seen the OnStar stuff recently. Yep. This is only going to get, I don't want to say it's only going to get worse, but it's only going to become more prevalent.
And what's funny is that it's not like these concepts have really changed. Like if you have ports, if you have any ports open or just ways to get in, those are attack vectors potentially, unless you have secured everything behind those ports very, very well. So it's just going to carry on.
Yeah, don't drive your car into a ditch as this guy is doing, not by his own volition, I guess.
Yeah.
So I mean,
that's the Jeep one where they were basically able to just kind of take over every aspect of the Jeep through the internet.
Yeah.
Yeah.
But the thing is, we have to remember we want that. I want cars to be able to drive themselves, and they're going to need some kind of global internet, like IP-based tracking system. So there's something monitoring everything, right? So you do want that to a certain extent, but you want the right people to do it and for the right reasons.
And to do it securely.
Correct.
Yeah, that's the key.
So I don't want my car just randomly driving into a ditch.
Yep.
But I do want, my car to be able to get firmware updates when it becomes a self-driving device over the internet and, do all that stuff.
Now, I mean,
I need OTAs
for these particular devices. I'm assuming that these things, even though they have FTP and Telnet open, like a lot of devices in a hospital on a hospital network probably have those ports open. But they're within the hospital network. Like the idea is to defend that.
No entry into the network.
That intranet should just be limited to within the hospital. In the first place, you shouldn't be getting in from the outside.
I will be honest with you too. All the IV pumps when I was at the hospital recently, like I never once thought that they were on Wi-Fi networks.
And they are.
I guess they are.
Yeah.
So I knew some devices were on a network, but like some of them, like the ones that were monitoring baby heart rate, were on a wired connection, because I can go back to the nurse station and see them monitoring the same thing.
And I would hope that it's only meant to be a one-way trip there, meaning it's just for data going back to the
reading,
nurse's station, not the nurse's station.
You can't remotely change what the rate of narcotic distribution is.
That would be horrible, right? Someone could someone else in the
it could be great.
Someone else in the hospital could if you could make that adjustment, like you don't want someone else in your hospital overloading your dad on morphine or something like that. That would be bad, right? No. So let's just hope that they're keeping those things secured sufficiently.
All right. And our last thing here, real quick, Corsair did launch a new, apparently Gamescom is going on. Oh, I did do that because that's where Intel officially launched Skylake, was at Gamescom for some reason. But Corsair launches a new set of RGB peripherals, the Strafe RGB mechanical keyboard, the Void RGB headset, and the Scimitar RGB mouse. And the keyboard, it's kind of like a lower cost version of the K70 RGB that we've seen.
Yeah.
Headset, I'm not sold on the headset look. I don't know. We'll see. I'm a big fan of the new Corsair gaming logo though. Or the new Corsair logo over the
keyboards.
Logo.
The keyboards are kind of up there on pricing, so I think they're just maybe just a newer version of the K70.
Well, I mean, it looks like there's less other connectivity. Like all the media keys and stuff all around.
Yeah,
it seems like a more basic RGB keyboard design. And then if you look at that mouse, do I need?
You could dial a phone number with your thumb.
It has 12. Is that 12 I'm looking at? 12 buttons on the side. Yeah.
That is.
I don't.
What games do you need that much?
you
I
know,
mean, I guess you could map them to all the weapons in a first-person shooter.
No,
you could map those to weapons in like a first-person shooter, and you can.
I mean, you could, or you could just use a scroll wheel.
Or yeah, I guess. But if you want to be able to go straight to that weapon, look, it has tire treads on the scroll wheel. It does.
I wouldn't even have the ability to like know which button I'm pushing of those 12 buttons.
Yeah, I don't.
Right, like. I don't know about the sense.
Memory.
I don't know about your guys, but my sense of touch and feel along this side of my thumb is fairly minimal.
I think it's meant for you to kind of move your thumb upwards and hit the other buttons.
It's a Scimitar RGB gaming mouse, 12,000 DPI capable. Probably don't use that DPI setting would be my guess. $79. So probably available in more colors than just yellow too, would be my guess.
I mean, it does look cool. It's just the buttons seem kind of overkill.
Yeah. All right, everyone, that is going to wrap up the show for this week. Thank you, everybody, for joining us. If this is your first time or one of your first times, go to twit.tv/twitch. That's TWiCH, This Week in Computer Hardware. Twit.tv/twitch. You can find all of the ways to subscribe to the audio podcast, the video versions, RSS feeds, anything you wanted to do, any of your pod catchers, if you will, can be supported by those file structures there. And we'll be back next week. Who knows who will be here to do the show next week? It is IDF, so I'll be out in the San Francisco area. So maybe I'll go up to the studio. I don't know. Actually, you know what? I think I come home Wednesday night. I think I actually will be home Thursday.
I will be at Flash Memory Summit.
Yeah, so we'll both be out of town, but I think I'm gone for a very short window. So we'll have that figured out. Hopefully Patrick will be back. Hopefully he makes it to wherever he's going to DEF CON. So he's going. I actually talked to him yesterday. He was taking a laptop. And I said, I wouldn't do that. And he said, well, it's one that it's like a throwaway. Like he's like, once I bring it back, it's just formatting it. I said, yeah, we did the same thing when Ken went to China. We just said, no, don't open that laptop anymore.
Don't
just
even
ship
turn
it back
on.
immediately. We'll be fine. We'll be good. So that's it for this, guys. We'll see you next time. I'm Ryan Schroep.
I'm Alan Mamatano.
Bye.